weak base. Weak base. So I told you about weak base when I was teaching you about electrolyte. I told you weak base means something which is not a very strong electrolyte, right? Weak electrolyte. Now there are that if you want to look at the solubility thing of a base, then you can classify the weak bases in two categories. Something which is soluble in water and something which is insoluble. My dear, insoluble in water means definitely it will be metallic hydroxide. Metallic hydroxide means like it will be magnesium hydroxide, it will be iron hydroxide. These are all which are not soluble in water, very less soluble, very less, partially. I mean 10 to the power minus 3 minus 4 mole per liter, that much only. So poor solubility. So this segment, and obviously these are ionic compounds. This segment we will be dealing with in solubility product. In the segment solubility product. Now the second category of the base, weak base, is not a metallic hydroxide, rather it is a compound of ammonia and its derivative dissolved in water. The simplest example is ammonia is a covalent molecule, guys. Ammonia in fact is a gas. Now if you dissolve in a aqueous solution, yes, it gets dissolved. It is soluble in water. And you know, any species will be said to be base when that is dissolved in water and the concentration of OH minus becomes more as compared to the neutral water condition. So if ammonia is dissolved in water, my dear, it simply promotes the ionization of water and takes the H plus ion and releases OH minus. So in many a book, this particular thing is written like this, which gives a wrong representation because people confuse and they think that this is an ionic compound plus and minus. It's not like that. It's not true. Rather, ammonium hydroxide, this name should not be used. Rather, it should be used as aqueous solution of ammonia is the proper word for this, rather than saying that ammonium hydroxide. Right? So, how it will be? Very simple. You can understand that it is a dipole, my dear. Partial negative. So, it will be attached with a hydrogen of water. And this promotes little bit the ionization of water and it forms basically NH4 plus and OH minus. That's what actually happening over here. So NH4OH, which I wrote, is not plus and minus, rather it is like this. This kind of hydrogen bonding is there. Right? So never get confused with that ammonium hydroxide is there. This is not a right way of saying it. Rather it is. So because ammonia is soluble in water, so promoting dissociation and OH minus concentration is increasing. That's why we say that it is a basic solution. So this type of base we will discuss. Now it is very similar to the case which we discussed in the previous video about the acid, the link for which is given in the description box. So how to solve it? Suppose, my dear, I took some C mole in 1 liter. So what will be the concentration of ammonia? C molar. So you write like this, or you simply write like this. But please remember, this is not an ionic compound. then it is basically dissociating like this. The equilibrium constant for this will be undoubtedly Kb then. And the equilibrium constant Kb is there, and then again if the concentration is C, C minus X, X and X. And if you want to know about degree of dissociation, amount dissociated upon initially taken. So X is equal to C alpha, so C minus C alpha over here and C alpha over here. Now the value of the Kb that we can write is concentration of this species or the concentration of ammonia, right? So if you'll write like this at equilibrium, then it will be simply Kb. I'm taking this term to the left side. C alpha, C1 minus alpha. From here, we got C alpha square upon 1 minus alpha is equal to Kb. Now, from here, my dear, this is the original equation. Now, suppose if alpha less than 0.05, then 1 minus alpha will be approximately 1. And the same equation will reduce the way we did. This time it will be Kb by C. And please check this. Check this value. With what? Whatever you assumed. Calculate alpha if it is less than 0.05. Okay, otherwise solve this equation. So this is the theory related to that. Now I would like to, take a question to demonstrate this and to solve this. So suppose a question is drafted like this, that find the concentration of ammonium ion. What is the value of this? If the concentration of ammonia, aqueous solution of ammonia is 0.02 molar and the value of Kb is 1.8 into 10 to the power minus 5. Now could you figure out this? It's very simple. Again, ammonia plus water forming this ammonium ion plus OH minus. The value of Kb is given to us. Now, the way we did it, that C1 minus alpha, C alpha and C alpha, I'm assuming if alpha less than 0.05, then alpha value is root over Kb by C. Let us calculate this. Kb is 1.8 into 10 to the power minus 5. And what is the value of C? 0.02. How much it will be? It will be 9 into 10 to the power minus 6. If I'm right. Sorry. Minus 4. Yes, sir? Minus 4. Do it, because this will be basically 2 into 10 to the power minus 2. So that will become minus 3. And this will be 0.9. If you convert it, this will be minus 4. Now, if you take out the value outside, this will be 3 into 10 to the power minus 2. Now, you know the value of alpha. Now, which is basically 0.03, right? Now, is this here we need to check. Is this okay with our assumption? So answer is yes. So that means we are on a safer side. We can accept that. Now, what will be the value of OH minus? That will be C alpha. So the concentration of OH minus will be what? C is how much? C is 0.02. And alpha is how much? 3 into 10 to the power minus 2. So overall, if you will do 6 into 10 to the power minus 4. Now you can calculate pOH, that is minus log concentration of OH minus. That is equal to minus log 6 into 10 to the power minus 4. So you can simply solve it. Break down A into B minus log 6 and minus log 10 to the power minus 4. So this will be basically 4, and this will be minus log 6 is minus log 2 minus log 3. So this will be 4 minus log 2 is 0.3 and minus log 3 is 0.47 approx. So you can solve this and you can figure out the value of pOH. If pOH is known, pH will be simply 14 minus pOH. Now this is how you calculate the pH. Now my question was, how much is the concentration of ammonium ion? Now how much is the concentration? Very simple, that is C alpha. So the concentration of ammonium ion is also C alpha, and that is also 6 into 10 to the power minus 4. Now similarly, the second question I would like to take here is, suppose if the two different molecule, one is acid HA and another is base BOH is given to you. That means HA in aqueous solution undergo ionization like this, equilibrium constant K, and in some different solution, because they are not taken together, in some different solution BOH is there, which breaks down into this, and that is Kb. Now the concentration, if I am taking, I mean everything is at 25 degrees centigrade. Suppose if I am taking the concentration of HA is 0.05. Sorry, 0.01 I am taking. And I'm saying that I found the pH of this solution is 5. Now, if suppose its concentration is 10 to the power minus 4, and now I want to figure out the pOH value. What else I want to give you here at the same temperature, obviously? I want to give you one additional information about this, that dissociation constant, that means the value of Ka and Kb are equal. If this is equal, then figure out the pOH of this solution if it is 10 to the power minus 4 molar. Now how to proceed? The first thing that you are supposed to calculate is what is the value of Kb, because if you will calculate the value of Kb, if that is known, thereafter you can proceed because initial concentration. And how will you know the value of Kb? Because of this relation. First let us figure out the value of Ka, because everything is given here. Now as you know that the HA is converting into H plus plus A minus, the equilibrium constant K, pH is 5, pH is 5, that means this is C 1 minus alpha, this is C alpha, and this is C alpha. The concentration of H plus ion is simply C alpha, and pH is already given to you, right? So pH is how much? 5, which means the concentration of OH, I mean if you want to write in terms of log, so this is basically minus log to the base 10 H plus ion. That is equal to 5. So that means concentration of H plus ion will be 10 to the power minus 5. So basically this value is 10 to the power minus 5. What is the value of C given to us? 0.01. So use this 0.01 C into alpha. is equal to 10 to the power minus 5. So from here, what we got, alpha to be 10 to the power minus 3. That is what we got from here. And now let us apply for the Ka. Ka, it will be C alpha square upon 1 minus alpha. Now look at the value of alpha is so low that at the bottom we can write in the denominator approximately 1. And now C, you already know, C is 0.01, which is given here. And how much is alpha? Alpha is 10 to the power minus 3 multiplied by 10 to the power minus 3 whole square. So how much we got? Minus 6 and minus 8. So this is, we got 10 to the power minus 8. That's what the value of Ka we have received. Now I'm interested in the value of POH. So how to get that? Very simple. BOH, B plus OH minus, value is KB. Again, through the same procedure, if C minus C alpha and C alpha and C alpha, if alpha less than 0.05, let us assume that it is less than 0.05, then the value of alpha will be root over KB by C, and the value of KB is equal to Ka, which was 10 to the power minus 8, and divided by 10 to the power minus 4, because the concentration we have taken this. That will be 10 to the power minus 4, and that will be basically 10 to the power minus 2, which is nothing but 0.01. Is it following our condition? Yes, 0.01 is far less than 0.05. That means this is true. Now, once this is true, I think the question is over now, because the concentration of OH minus will be what? C alpha. And C is how much? 10 to the power minus 4. Alpha is how much? 10 to the power minus 2. Overall, it is 10 to the power minus 6. Very close to water. Very, very close to water, because water's value, pure water, there we used to get 10 to the power minus 7, if you remember, at 25 degree. Very close to water, but still at least 10 times greater than that. So approximately we can take this, but it will not lead us to a very accurate thing, because even if you will try to write that TOH simply minus log 10 to the power minus 6, it will not be very true, because the concentration of OH minus is this along with 10 to the power minus 7. Even if you add them, technically you should solve equation by considering water also, but I don't want to make it lengthy. So if anyhow it is a subjective question, if that is asked, then answer will be close to 6. POH will be close to 6.